all the technical topics are over. It is just summarizing the things what we have understood. So for eager troubleshooting, verify the sampling strategy, use the logging reporter, bypass Jaeger agent, increase the logging and backend components, check the slash matrix endpoint, and run debug images of the backend components. This is what you these inputs will help you in troubleshooting eager. Verify the sampling strategy. Before everything else, make sure to confirm what sampling strategy is being used. By default, Eager use a probabilistic sampling strategy with thousandth part, 1000th chance that span will be reported. For development purpose or for low traffic scenario, however, it is appropriate to sample every trace. It can be set to Eager sampler type and Eager sampler parameter. Refer to the Jaeger client documentation for language you are using for more details about which sampling strategies are available for that specific language. Like for example, if you are using Java, when using Java client, the strategy is printed out via the logging facility provided by instrumented application when creating the tracer. Info, for example, configuration, initialization, tracer, and important point is this sampler type is constant and sampler parameter is true. When diagnosing why spans are not being received by another component, make sure to configure these two sampler type environment variable to constant and eager sampler parameter to 1, because in Java you have implemented this, that sampler type is constant and sampler parameter is 2. If you recollect, all these parameters what you appear in lowercase, they have corresponding environment variable. You convert every character to uppercase and character every punctuation mark to underscore. So sampler underscore type, eager sampler underscore type, and eager sampler parameter. That's what the environment variable should be. So it should be constant and parameter should be 1. This is for Java. Using logging reporter, use the logging reporter. Most eager clients are able to log the spans that are being reported to the logging facility provided by the instrumented application. It can be done by setting eager reporter log spans to true. In Go and Node.js languages, there are no de facto standard logging facilities. So you need to explicitly pass a logger to the client that implements a very narrow logging interface defined by Eager client. When using Eager Java client, spans are reported like this. This is span details, info details, span reported, and the details. This log entry contains what? The trace ID. Trace ID is first value E66 DC up to this point 3B. The next column is span ID, and then after that we have span's parent ID. So this is what you have the details about it. So you this log entry have all the details. When the backend component have the log level set to debug, the span and trace ID should be visible on their standard output. The logging reporter follows the sampling decision made by sampler, meaning that if span is logged, it should also reach the agent or the collector. Bypass the eager agent. Sometime for troubleshooting it becomes interesting and required. By default, eager client is configured to send spans via UDP to a eager agent running on localhost. As some networking setups might drop or block UDP packets or impose size limits, the eager client can be configured to bypass the agent, sending spans directly to the collector. Eager Java client supported the environment variable eager endpoint, which can be used to specify the collector's location like eager collector port number API traces. So refer to the client documentation for the language you are using. Bypass eager agent. When you have configured eager endpoint properly in the eager Java client, it logs this following when the traces is created, like here sender http head sender, this one. If your eager backend is still not able to receive spans, then the issue is most likely with your networking namespace configuration. When running the eager backend components as Docker containers, the typical mistakes are not exposing appropriate ports outside the container. For example, the collector may be listening on port number 14268 inside the container network namespace, but the port is not reachable from the outside. Second, not making the agents or collector's hostname visible from the application's network namespace. For example, if you run both your application and eager backend in separate containers in Docker, they either need to be in the same namespace or the application's containers need to be given access to the eager backend using hyphen hyphen link. That is the communication between two containers. Increase logging in backward backend components. The eager agent and collector provide helpful debugging information when the log level is set to debug. Every UDP packet that is received by agent is logged, as well as every batch that is sent by agent to the collector. The collector also logs every batch it receives and logs every span that is stored in the permanent storage. Here's, here's what you expect when the agent is started with hyphen hyphen log level equal to debug. So here you'll see the complete debug, level is debug, and rest all the details, caller and all rest of the details. On the collector side, expected log entries when log level debug is specified. This is what you expect on the collector side. So level is debug TS and the caller app span handler go language and message processed by the collector. So by collector you are getting this message. So this is for log level debug in the collector side. Check the matrix endpoint for the cases where it's not possible to or desirable to increase the logging on the collector side. Slash matrix endpoint can be used to check if spans for specific services are received or were received. The matrix endpoint is served from the admin port, which is different for each binary. Assuming that the eager collector is available under a host named eager collector, here's the simple curl call to obtain the matrix. Eager collector, port number, and the matrix. This is how you can simply curl it. This following metrics are of special interest, like eager collector span received, span saved by SVC, traces received, traces saved by SVC. First two metrics should have similar values for the same service. Similarly, the two traces matrix should also have the similar values. For instance, is an example of setup that's working as expected. Like eager collector spans received, debug is false, format is eager, SVC is order. So this is what you are expecting. Similarly, this one is false, debug is false, format is eager, SVC is order. This is the endpoint that will help you. Run debug images for backend components. Debug images for each eager components are provided. These images have dev and respective eager components compiled with optimization disabled. When you run these images, dev triggers the execution of eager component as its child process and immediately attach it to begin a new debug session and start listening on port number 1, 2, 3, 4, 5 for remote connections. You can then use the IDE like Visual Studio Code or Go language to connect to this port and attach with it remotely and perform debugging by attaching endpoints. adding the breakpoints. So run debug images of backend components. For Visual Studio, you need to have following configuration as at the root level of your local clone of Eagle source code. VS Code, launch.json, and this is what version, configuration, name, launch remote, type is go, attach remote, remote path is blank, port is 12345, host name is localhost, and command is workspace root variable. That's all for this quick session. I would like to continue with the next session without any break, and that is best practices. Session number 20, best practices. Metric and label naming. The metric and label conventions presented in this session are not required for using Prometheus but can serve as both a style guide and collection of best practices. Individual organizations may want to approach some of these practices, for example, naming conventions differently. So metric names. Metric name must comply with the data model for valid characters, should have a single word application prefix relevant to the domain of the metric belong to. The prefix is sometimes referred to as namespace by the client libraries. For metrics specific to an application, the prefix is usually the application name itself. Sometimes, however, metrics are more generic, like standardized metrics exported by client libraries. Now look at the example. Prometheus notification total, process CPU seconds, HTTP request duration. So this first prefix is telling you what kind of metrics it would be. Must have a single unit. Do not mix seconds with milliseconds or second with bytes. Should have base unit like seconds for time, bytes for memory, meters for distance, not millisecond, megabyte or kilometers. So these are base units you need to remember based on your monitoring requirement. Time, base unit is second. Temperature, base unit is Celsius. Length, base unit is meters. So bytes, bits or bytes, base unit. Percent is ratio. Voltage is volts. So use these base units. Metric name should have suffix describing the unit in plural form. Note that an accumulating count has total as a suffix in addition to the unit if applicable. For example, at HTTP request duration seconds, so S, uses bytes, requests total, so it is request and total. CPU seconds, so CPU seconds total. Build info, this is a pseudo metric that provides metadata about running binary. Should request the duration, bytes for data transfer, instantaneous resource uses as percentage. Present the same logical thing being measured across all the label dimensions. Use labels to differentiate the characteristics of the thing that is being measured. For example, API HTTP request total. Differentiate request type. For example, operation, create, update or delete. API request duration seconds. Differentiate request stages. For example, extract or transform or load. Do not put the label names in metric names, as this introduces redundancy and will cause confusion if the respective labels are aggregated away. Console and dashboards. It can be tempting to display as much as data as possible on a dashboard, especially when systems like Prometheus offers the ability to have such rich instrumentation of your application. This can lead to consoles that are impenetrable due to having too much of information that even an expert in the system would have difficulty drawing meaning from. We have found these following guidelines very effective. Have no more than 5 graphs on a console. Have no more than 5 plots in each graph. You can get away with more if it is an area or stacked graph. When using the provided console template example, avoid more than 20 to 30 entries in the right hand side of the table. Histograms and summaries. Histograms and summaries are more complex metric types. Not only does a single histogram or summary create a multitude of time series, it's also more difficult to use these metric type correctly. Alerting. To summarize, keep alerting simple. Alert on symptoms. Have good console to allow pinpointing causes and avoid having pages where there is nothing to do. What to alert on? Aim to have as few alerts as possible. By alerting on symptoms that are associated with end user pain rather than trying to catch every possible way that pain could be caused. Alert should link to relevant console and make it easy to figure out which component is at fault. Allow for slack in alerting to accommodate small blips. That's all for this session. Thank you very much.